So, hello everyone. My name is Mark Bachinger. I'm a developer advocate here at Google. I'm a member of the media team, so I'm usually working with large media partners, audio and video partners to improve the streaming experience of their app. So usually this boils down to integrate ExoPlayer or to help them migrate to ExoPlayer. So let me start with one of those mandatory instant service just to cool down the speaker a little bit. Who of you have watched a video on YouTube in the last week on Android? Yeah, not surprisingly, a very good number. So all of you who raised your hand, you already are ExoPlayer user because ExoPlayer is the default video player in the YouTube app. So let me start with the first slide with a website I found some years ago or some months ago on the internet. It's obviously not a Google website. It's a website some YouTube users did. It's the YouTube ExoPlayer guide, and there were some users that found that YouTube started using ExoPlayer within the YouTube app, and they found the experience so exciting that they found ways to kind of hack YouTube to force YouTube to use ExoPlayer all the time and on all devices. So there is a very nice quote on this website. This quote says, "ExoPlayer is an experimental video player hidden inside Google's YouTube app. It loads videos much, much faster, but made unavailable to the average person." So let me be clear, most of this quote is not true. So ExoPlayer is not at all experimental. ExoPlayer is not hidden inside the YouTube app, and it's not unavailable to the average person. I may agree to the thing in the parentheses, it loads video much faster, so that's the improved video experience we want to have from ExoPlayer. So again, let me be clear, that's not true. It's available on GitHub. You can download it on GitHub. So what is ExoPlayer then? ExoPlayer is a so-called application-level media player library. Application-level media player library means you can include the library within your APK, within your app, and ship it to your user with your APK. Regarding the living room, ExoPlayer is a perfect choice. All Android TV devices support ExoPlayer. Android TV devices run on Lollipop and Grater, so all those devices support ExoPlayer. But ExoPlayer is not only a good choice for TV, it's also an excellent choice for mobile. All devices support which have API 16 and greater support ExoPlayer. So I have this number here, 95.7%. This is the share of Android devices running API 16 and later. So that's a quite good number for all devices out there. ExoPlayer is built on some public APIs provided by the media framework. So to say this clearly, ExoPlayer does not use some kind of hidden APIs or private APIs only available for Google Tech. ExoPlayer really uses public APIs. It's the Android Media API on the one hand and the Android Media DRM API on the other hand. So at least in theory, you can write such a player for yourself. But that's, of course, not a really easy task. That's why we released ExoPlayer some years ago as an open source product on GitHub. So you can include it into your apps as well. So what is such an application-level media player? I already mentioned you can include this library in your APK and ship it to your users as part of your APK. We see here this white box at the top. This white box is the APK, which contains an application-level media player on, in this case, ExoPlayer itself. And now this application-level media player or ExoPlayer uses those APIs available. This diagram here is ExoPlayer in an early version. Today, it looks a little bit in other ways. We will have a look at this later. We see those arrows. ExoPlayer is using the Media Extractor API, it's using the Media Codecs API, and it's using the Audio Track API. All of those are public APIs available on Android. When you have a little bit a look at the gray boxes, we have this media extractor with those green boxes in it. So this is what a streaming video player has to do. First, we have to download container data from the internet. Then we have to buffer this data until we really need it. And once we need the data, we need to extract audio and video samples out of the container. When we have those samples, those audio and those video samples, they are still encoded, so we can't really render those. So we need the Media Codecs API to decode those samples. And once we have those samples in a decoded way, we can render those with Android. In a case of video, we only have to pass a surface to the Codecs API, and the Codecs API itself then does the rendering on this surface. In the case of audio files, the result of passing these encoded frames is, or PCM frames, so PCM frames which we then can play by using the audio track. So that's what is involved in both, in audio streaming and in video streaming. And there's still a little bit a problem with this diagram. So all those tasks are kind of buried in the APIs of the framework. So if we want to customize or we want to kind of change the behavior regarding those tasks, there is nothing we can do because everything is done by the framework, which we can't really customize. ExoPlayer uses, or the early versions of ExoPlayer used this framework sample source class. This framework sample source class used the media extractor API to do this networking, buffering, and extracting tasks. And that's what we also see in the next slide, a little bit more focused. But still, the framework sample source can't really influence what media extractor is doing in detail, and that's exactly what we want. So the ExoPlayer team, in the end, decided to deprecate this framework sample source and to do all these tasks in ExoPlayer itself. So the diagram, which we have seen before, now looks like this. So all those green tasks are moved into the ExoPlayer, so are moved into the APK, and that's why we now can customize the behavior of those tasks. So if you want, for example, to use another network stack, you can use another network stack by using a custom data source. You can influence buffering, and you can even support other containers, other video or audio containers which are not supported by the framework. So by moving those tasks into the realm of ExoPlayer itself, we win some customizations. That's exactly what we want. Regarding the other two media APIs, there is not much we can win by replacing them. Usually, the media codecs uses hardware-backed functionality to decode those frames and to do really an efficient job, and that's something we never want to do in software. So this still is done by those media APIs provided by Android. The same is true for the audio track. There is not much sense to play audio in another way than with an audio track. So why should you, as a developer, use ExoPlayer? What are the advantages of using ExoPlayer? First of all, there are those streaming formats like Dash and Smooth Streaming. Those two are not supported by the media framework itself. So if you want to use Dash or Smooth Streaming, you need to use something else than the media player, the player of the framework. And of course, what we recommend is using ExoPlayer, sorry. HLS is also supported by ExoPlayer, and it's also supported by Media Player. In this case, if you already use HLS with the Media Player and you are okay with that, there is nothing against using Media Player, but for some reasons, we also support HLS with ExoPlayer. Another advantage is, as I already said, you can include ExoPlayer as a Gradle dependency within your app, and you can ship ExoPlayer or this library with your APK to your users. The biggest advantage of this is that you are really sure that every user is using the very same version of your player. That's a very interesting feature, because if you are using the media framework and one user has an older device, he will use another player version than a user with a newer device. And if you have to debug problems or so, you always have to make sure that you are testing the very same version. With ExoPlayer, that's kind of easy because you can say which version you ship with your APK. Besides this ability of using the very same version, you also can take advantage of the faster release cycle of ExoPlayer. ExoPlayer sometimes releases new versions within months. And you know, with Android devices, that's something a little bit different. Some devices are updated very rarely. So if you have to wait for a bug fix for a framework component, for some devices, you will never get these updates. So with ExoPlayer, you can just include the new version of the library in your APK and ship it to your users. And in the end, the most interesting features for some developers is the ability to customize ExoPlayer. That's exactly what we have seen in the diagram before. By moving those tasks of networking, buffering, and extracting data from the containers, we gain some customization, some means to customization those tasks, and that's exactly what we want if we have some specific requirements to meet within your apps. For Android TV, of course, ExoPlayer is a very good choice. If you want to support 4K, ExoPlayer is ready for 4K. So if you have 4K content which you want to bring to your users, ExoPlayer is a very good choice. ExoPlayer also is ready for some very modern audio codecs like Dolby Digital, for example. If you have connected your Nexus player, for example, to a TV which supports Dolby Digital, ExoPlayer can recognize this if the TV advertises support for those codecs by HDMI. And then ExoPlayer will just pass through the encoded audio data to the TV, and the TV will do the decoding and the playback of those modern audio codecs. One of the customizations which we see very often on Android TV is that you can customize the bitrate algorithm, the bitrate adoption algorithm. You know, the Android framework is still made for and optimized for mobile. So if the media player starts doing adaptive playback, it starts with the lowest video quality. If you are on a mobile network, that makes perfectly sense because you want to start playback as soon as possible. So the media player starts with the lowest quality. On Android TV, that's a little bit different. All Android TV usually are connected by Wi-Fi to the internet or even by Ethernet. So you have good bandwidth. And so you may want to start not with the lowest, but maybe with a medium video quality to have a very good quality for your users very quickly. So if you want to customize this bitrate adaptation algorithm, ExoPlayer is a good choice. And in the end, then, ExoPlayer is also ready for content protection. Android TV does not only support wideband, it also supports Play Ready. And with ExoPlayer, you can use wideband or Play Ready for both for Dash and smooth streaming. In fact, ExoPlayer supports common encryption, which includes support for those products available on Android TV. A question which comes up very quickly when I talk to my partners, so yeah, which media formats are supported by ExoPlayer? That's not really an easy question. So let's start with the first row of this table. Let's start with the streaming formats. I already said it's Dash and smooth streaming and HLS. These are the streaming formats which are supported by ExoPlayer, while HLS is also supported by the media framework. Only ExoPlayer supports Dash and smooth streaming. Container formats are the very strength of ExoPlayer. We have seen that we move those green boxes into the application space, so ExoPlayer does extracting data out of these containers itself. This means ExoPlayer can support arbitrary containers, and it can support more containers than the framework does. So we have here a couple of common container formats. So there is MP4, of course, there is WebM, Matroska, which is supported by ExoPlayer. There are a couple of audio containers like MP3, OGG, and WAV. And then there are the HLS container formats, MPEG-TS, MPEG-PS, and ADTS. When it comes to video and audio formats, ExoPlayer can do this itself. The decoding of those video formats and audio formats is just delegated to the media framework. So ExoPlayer supports all those formats which are supported by the media framework. There is a web page on developer.android.com which you can consult to see what what video and audio formats are supported. Another important type of formats are closed captions and subtitles. For professional media companies, this is a very important feature they have to provide sometimes for legal reasons, closed captions and subtitles. So that's very important. ExoPlayer supports TTML and WebVTT for dash and smooth streaming. These are the most common formats for dash and smooth streaming. And it supports 608 for HLS, the format which usually is used with HLS. Another question which comes up very quickly. So if I have to put this player library into my APK will get bigger. And some developers are afraid of maybe hitting the DEX limit. You know, there are a certain amount of methods which you can include in your DEX file. So that's a very important question, how many methods are included with the ExoPlayer library. The numbers which we have here, it's the kitchen sink library, so it's the very highest number you can get. If you ProGuard your APK, usually ProGuard is able to remove a lot of those methods, so because usually you don't use HLS dash and smooth streaming in one APK, you use only one of those streaming formats, and so ProGuard is able to remove many of these methods. I did a audio application, a little audio application, and then ProGuard removed about 2,000 of those methods. I ended up with having about 900 methods for an audio playback application. Who is using ExoPlayer already? Also a very important question. You don't want to beta test Google software with your users, of course. You want to have well-tested software in your APK. So Google itself uses ExoPlayer in their most famous application. YouTube, I already mentioned, is using ExoPlayer. There's also Google Play Movies, which is using ExoPlayer on mobile and on Android devices. And the last Google application is Google Fiber, which also relies on ExoPlayer for doing video playback. I already mentioned I'm working with large media partners, and there are a couple of large media partners which also use ExoPlayer internally. We usually do not expose these partners, but I can assure you there are really large companies using ExoPlayer like Google does. Yeah, and hopefully soon you will use ExoPlayer too. If I'm a little bit convincing today, you will download ExoPlayer, and once you downloaded ExoPlayer, I'm pretty sure you will like it, and soon you will include it in your APK as well. So let's have a look at some basic use cases. And for a media player, of course, basic use cases is playing audio and video files. So what do you have to do to play audio or video files with ExoPlayer? The third thing is, of course, including ExoPlayer in your APK. The easiest thing to do this is just add another Gradle dependency to your Gradle files, and then ExoPlayer will be included, and you can use all those classes available. When you are using ExoPlayer, ExoPlayer has the concept of track renders. You need a track renderer for every type of data you want to render. Usually, you have audio data, video data, and text data, namely subtitles or closed captions. So in a full-fledged video application, you have 3 track renders. For this use case of doing audio playback, there is only 1 track render needed. And that's exactly what we see in this highlighted code snippet here. We are we require such a track renderer. In this case, it's a media codec audio track renderer. So the interface is a track renderer, and the concrete class implementing this interface is a media codec audio track renderer. This media codec audio track renderer now takes a couple of arguments in its constructor, and the most important one is the first, or the most interesting one is the first argument, the sample source. The sample source is a collaborating component. So the media codec audio track renderer requires a sample source to get audio data or audio samples from it. That's exactly what we see now in the next line of code. Here we are creating such instance of a sample source. Again, we have the sample source, which is only a Java interface. The concrete implementation then is an extractor sample source, and the extractor sample source is provided by the ExoPlayer library. Here again, a couple of arguments in the constructor. The second constructor is of interest here, the data source. The data source is again another collaborator, which then is created in the line above. Again, we have a data source interface, a Java interface data source, which is then provided as a default URI data source. And now with the very same pattern again, the default URI data source needs a bandwidth meter, and again, this bandwidth meter, a concrete implementation of bandwidth meter, is provided by the ExoPlayer library. So we kind of wire up a chain of components, each depending on another component, and it's kind of obvious that it's kind of easy to create your own implementation of one of those interfaces. If you have such a custom implementation of such an interface, you can just instantiate it and inject it into the constructor of the other components. Those arrays highlight this pattern a little bit, so we create one component and inject it into the other component to get a chain of those components. So once we have this audio renderer, or this track renderer for audio, we need to kind of register those renderers in the ExoPlayer itself. So we create an array of track renderers, assign the audio renderers to one of the position of this array, and then we pass it to the onRenderers method. So this was what we need to do for doing audio playback. For video playback, as I already said, we have some other type of data. There is not only audio, there is also video data, and eventually you want to render text, subtitles, or closed captions as well. So again, we need 3 of those chains of dependent components. So we need a track renderer. The track renderer then needs a sample source. Each sample source, again, needs a data source, which in the end needs a bandwidth meter if you want to do adaptive playback. So let me be clear again, you don't have to provide your own implementation. Each component has a default implementation provided by the ExoPlayer library. You can kind of wire up your renderers as you want. So there is no need to really implement these things. If you don't have specific requirements, you can just use it as the demo application does demonstrate it. Besides these track renderer components, there are a couple of UI components available as well. So these components are not really mandatory, but they are very convenient to use. There is, for example, this aspect ratio frame layout. It's a layout which makes sure that the surface view on which the video is rendered is always resized nicely. So if a user, for example, changes the orientation of a mobile device, you have to resize the surface view to match the size of the viewport. Another component is at the very bottom. This is the subtitle layout. Again, this subtitle layout is in the end optional to use, but if you want to render text or closed captions or subtitles, it's very convenient to use. It's the same size as the entire layout or the surface view has, and it's kind of a layer above the video on which ExoPlayer can render those subtitles. So there's a lot of going on. We have seen that you have to download data, we have to buffer data, we have to extract data out of the containers, and in the end, we have to render this data to a surface or to the audio track. So there is a lot is going on in this video player. If you want to be aware of what is going on, you can implement some listeners and then register those listeners. So on a high level, there is the ExoPlayer.listener. This is a listener which notifies you about the high-level state of the player. So when you start, the player is in an idle state, and it transitions to a buffering state. So we have to start downloading data, and as soon as there is enough data, we can start playback. If you want to give some signals to your user, now the player is buffering, there is not enough data available, you can just implement such a listener and listen to those state transitions. Besides these high-level events, there are a couple of low-level events. So there are many of those components which you have to wire up, and each of those components has an event listener. So we see here that the demo player, this snippet again, is out of the ExoPlayer project. It's from the demo player application of ExoPlayer. It implements an event listener for each of those components. So whatever is going on in one of those components, your application is aware of what is going on, and you can act upon this these state transitions. So let's have a look at the architecture or design. We now have seen that there are many such components which are dependent on each other. And so let's have a look at the diagram. This is a diagram of the component model or the object model which is required to do traditional media playback. Traditional media playback is so-called non-adaptive playback. So there is one single container file sitting on a server on the internet somewhere, and we need to download this container, and then we need to extract data out of these containers. That's exactly what we need for such traditional media playback is, again, we need to track render. We have these blue boxes on the right. This is a media codec video track renderer and a media codec audio track renderer. Those two are responsible to kind of render audio and video track video data by using the public media APIs. Each of those track renderers is now dependent on an extractor sample source. This extractor sample source uses an extractor. In this case, it's an MP4 extractor, which knows how to extract audio and video data out of this MP4 container, then passes the sample to the extractor sample source, which again passes it to the track renderers for rendering. So if you want to support some kind of a custom container format, maybe you invented a super efficient container format for video, you can just create your own extractor, register this extractor with the extractor sample source, and then you can support this new kind of container. Maybe you have some kind of content protection built into the container. If you have invented such a container, you can also kind of plug in these container formats with ExoPlayer. And in the end, at the very left, we see the default URI data source. Again, this is an implementation of the data source the extractor sample source relies on. And if you want to, for example, support a proprietary network protocol, you can implement your own data source here to support those protocols. So the next diagram shows the same object model for adaptive media playback. The difference here is that the video player has to pick the quality of the video chunks. So again, on the very right, we have those blue boxes. It's the media contact video track renderer and the audio track renderer, which does the rendering at the end. Those two now are dependent on a chunk sample source, and the chunk sample source itself depends on a dash chunk source. The dash chunk source is now the component which knows the manifest of dash. So in the manifest, there are references to video chunks of different quality, and as soon as we know that we have good bandwidth, good network bandwidth, ExoPlayer should pick a better quality over a lower quality. The dash chunk source then again relies on a data source to actually do the downloading. Again, you can replace these components if you want. The most important thing here now is the adaptive evaluator. The adaptive evaluator does some metering of the network speed. So as soon as usually we start with a low quality, or in case of Android TV, we start with maybe a medium quality of those chunks. And the adaptive evaluator does meter the bandwidth of the network as soon as we start downloading data. I already mentioned that this bitrate adaptation algorithm might be a candidate you want to customize. And if you want to, you can only replace this tiny component of the adaptive evaluator to not start with the lowest quality, but maybe with a medium quality, and then replace this component when you wire up this object model. So you really have just to replace this tiny piece of this object model, provide your custom implementation, and then in the end, they work together nicely with the default components delivered by the ExoPlayer library. So yeah, you may say, yeah, but that's really a complex thing to wire up all these components. If I use Media Player, I just have 2 lines of code and it starts playback. And yeah, that's true. This flexibility or this ability to customize things comes with the price of this added complexity. But the good news is that ExoPlayer provides some templates to wire up these objects together. There are templates for Dash, smooth streaming, and HLS, for example. We have, for example, the Dash render builder, which does wire up the component model for doing Dash streaming. Usually, you don't have to change these templates. You can just use it as it's provided by the ExoPlayer library. If you have some specific requirements, you have some specific features within your Dash manifest, for example, maybe you have to adapt what the Dash renderer builder is doing. But again, it's a very good start to look into these renderer builders. These renderer builders, again, are part of the demo application. So if you download the project and you have a look at the demo application, you will find these renderer builders and can start from there. The last renderer builder which is available is the non-adaptive playback. It's again for traditional media playback, and it's pretty much the same. It's not that complicated. We have seen the diagram. There are less components which work together, but if you want to do traditional playback, again, you can start with this extractor renderer builder. So yeah, now call to action. So of course, we have some call to actions for you. So clone the ExoPlayer project. It's available on GitHub. Easiest thing is just to search for GitHub and ExoPlayer, and you will find the repository. Clone the repository, build the APK, and deploy the APK, the demo application, to your Android device, and then start testing. The demo application includes a list of sample streams. There are sample streams for Dash, smooth streaming, and HLS. There are sample streams for the different content protection technologies. This is like Widevine and Play Ready. And check it out. And if you find your streams you want to support, it's quite easy to start from the demo application. And in the end, of course, integrate ExoPlayer as a library into your own app. Take the demo application as a template, and then use ExoPlayer by integrating it with a Gradle dependency. There are other ways to do that. You can copy the source code into your APK, or you can build a library and then put the library in your IDE. But the easiest way is just to use a Gradle dependency. So that's basically what I have. So there are, again, those links to the ExoPlayer project itself, and there is also a reference to the developer guide. The developer guide gives you in-depth information about customizing ExoPlayer for your needs. All those diagrams we've seen in this talk are taken from the developer guide, so it's a pretty good read for you if you want to meet your requirements to check out ExoPlayer, the ExoPlayer developer guide. Yeah, that's all I have. So if you have some questions, please go to the microphone and ask questions so everybody can hear it, and I'm happy to answer these questions.
Hey, is the player support 360 video as well?
Excuse me?
360 videos.
No, ExoPlayer currently does not support. I think the YouTube has a kind of a modified version, but currently no support for 360. Excuse me? Sorry.
It's a custom model.
Yeah, currently no support from ExoPlayer's project, yeah.
Whoa, that came on all of a sudden. Is there a roadmap for the ExoPlayer, and is there any kind of reliable way that we can influence what's coming up in the project?
There is not a public roadmap. There is on GitHub, there are different branches. We have the productive branch, and then there is the development branch. If you look into the development branch, you look a little bit into the future. There is also currently an experimental branch. We are working currently on version 2 of ExoPlayer, which brings in some more flexibility, especially at runtime. So all those components will be about the same, but at runtime we have more ways to kind of replace components at runtime. So, but there is not something like a public roadmap available. If you are interested in the feature, I can just go to the issue tracker of GitHub, and the team is there and will answer about about the plans of the team.
Thank you.
Welcome.
Why HLS is supported both for media player and ExoPlayer? HLS is supported both for media player and ExoPlayer.
Mm-hmm.
What is the reason for that?
Yeah, I don't know actually. So I mean, HLS is a very popular format, and then it was included into the framework itself. Media Player supports HLS, and then as soon as we started with ExoPlayer, I mean, it makes sense to support all those most commonly used adaptive formats. So yeah, good.
How user choose which one is better, ExoPlayer or media player?
Which one is better?
Yeah.
It depends. So you can try your streams if you are okay with what Media Player can do. It's okay. If you want to customize the behavior, that's in the end the thing. If you want to adjust the player to your requirements in the app, I would recommend to use ExoPlayer. But I mean, if one of those works for you, both are okay. So there's no reason to use one over the other.
Yeah, we can try it.
Yeah, exactly. Yeah.
Mm-hmm. One more question is okay.
Mm-hmm.
Which protocol is used for in the YouTube application?
Oh, I don't know.
I don't know.
I don't know about the internals of the YouTube application, sorry.
Oh, okay. Yeah, thank you.
You're welcome.
Hi, Mark. Thanks for the presentation.
Welcome.
So from our experience when we used ExoPlayer, some of the lower-end phones, our experience is that sometimes the video stutters, sometimes the video doesn't play at all. Like, do you have any recommendations how we can figure out if a phone supports ExoPlayer or not?
Yeah, it's hard to say what the reason is, because I already said, so especially when it comes to decoding, ExoPlayer is using the framework clauses or the framework API as well. So and those APIs usually are provided by the vendor, by the OEM, which provides the device. So there are different implementation on each of those devices. And if there is a problem on certain device, it may be that it's just on this device, and it's very hard to say in general what the problem is on on these devices. Maybe I would recommend to create a bug report after you experience this problem and put this bug report into an issue on GitHub and ask the ExoPlayer team if they know about a common issue with these devices.
Can I ask a follow-up?
Okay.
So from my understanding earlier, you were saying that the YouTube app is using ExoPlayer by default. Do you know how they handle it?
No, sorry, I don't know about the internals of YouTube app. So.
Okay, cool. Thank you.
Welcome.
Hi, Mark. One quick question on the video and audio rendering implementation. Do you have plans to support sideband and tunneling?
Support what? Sorry.
Sideband. You know, in HL, sideband and tunneling.
No, I don't know about it, but maybe we can talk offline about it, and then I can ask the team.
Yeah, thank you.
Welcome.
Yes, one question on the ExoPlayer. Does the ExoPlayer have the capability to extract metadata from the video and display it, overlay it on the video?
From what format?
So let's say if your video source has some metadata built into it, like MPEG-4 Part 10, you have on the packer header, so you can put metadata on that. Does the ExoPlayer have the framework to extract that metadata and overlay it on the video?
Good question. I don't know for MP4. I know, for example, for HLS, we are extracting the ID3 tags, and then you are able to kind of get the information from these tags.
Yeah, that's different from the closed caption. That particular slot on the packer header
Yeah,
is
yeah,
different.
yeah.
Does this, I mean, we looked at the developer guide. I didn't see any references to the metadata.
Yeah, I'm not sure. Maybe also let us check offline, and then
Okay.
I can help you maybe.
Hi, Mark.
Yeah.
The ExoPlayer support DRM content.
DRM?
DRM.
Yeah.
Digital right management.
Yeah. It depends on what adaptive technology you are using. If you are using HLS, AES 128 is supported, and for Dash and for smooth streaming, we support common encryption. So, for example, Widevine and Play Ready on Android TV or Widevine on mobile devices.
How about OMA?
Sorry?
OMA.
OMA, I don't know. So, in general, if you really want to have very good security, you have to use one of those DRM technologies which are available on the devices, because they need the keys to be in the hardware. And so I think if you want to really secure solution, you have to use Widevine or Play Ready.
So how about Android TV? Can we use ExoPlayer on Android TV to play the DRM content?
Yeah, sure.
Yeah.
Yeah, sure. You can use Widevine and Play Ready on Android TV.
Cool. Thank you.
So maybe the last question. Yeah.
Yeah. Hi. So I had a question on how do you detect cloned Android devices from the perspective of the ExoPlayer? Also, can you say something about the ad insertion capabilities?
Yeah, so there is nothing specifically for ad insertion currently in ExoPlayer. So we have partners which do this for themselves. So you have to kind of, that's exactly one of the fields which ExoPlayer is very good at. You can replace one of those components and do the ad insertion itself. But there is nothing provided out of the box.
Okay. What about the cloned devices? Is there a way to detect?
What devices, sorry?
Cloned, let's say I have a cloned instance of a valid, like a virtual instance of a valid Android install, and I'm running that from the ExoPlayer, or I'm running the same ExoPlayer, same content on it. Is there a way to detect whether a device is a clone device or a real device?
Not built into ExoPlayer. You have to do this for yourself as well.
Okay,
Yeah.
thanks.
Okay, thank you. So thank you very much for your attention.